Hello everyone, my name is Ranjan Behera. This is my final project and I have used Spark, Python and NIME analytics platform to solve the big data problem. Apache Spark is fast in-memory data processing engine with inbuilt development APIs and libraries. Spark is very easy to use. It can be implemented with many languages including Scala, Python and R. NIME analytics platform is an excellent open source with powerful analytics tool. NIME integrates variety of components for machine learning through its modular data pipelining concept. My problem statement is to predict the customer purchase intention on e-commerce website clicks by using clickstream data provided by uchoose.net. I will be using NIME analytical platform to predict the purchase. Here is my environment and technology. I have used CentOS 7 virtual machine with Linux along with Spark and Python installed. Spark version is 2.3.1, Python version is 2.7.5 and NIME 3.7.0 analytical platform. My hardware environment, I have Windows PC with Intel Core 8 CPU i7. To get it started, I have downloaded the file from uchoose.net site and copied into my virtual machine. For my analysis, I am interested on two sets of data. Clicks has 33 million of rows and 1.4 gigabyte of size. Buys has 1.1 million of rows with 55 MB of size. Click dataset comprises of all the clicks when user clicks from the website. The buy datasets will have entries if the user ended up with any purchase from the website. Both files have session IDs in common and can be linked. Here is the overview of install, configuration and setups. I use NIME analytical platform and can be installed from the link given here. Data downloaded from the site given here. Since the size of the file was around 2 GB with 33 million of clicks and I have two files to merge, I had to combine these files and select a subset of data sample for my prediction model. I use parse SQL and Python data frames for parsing, combining and reducing the data. Later, this particular file will be input to the NIME analytical platform for prediction. So the final file structure has session ID, total clicks, total time and buy. Let me run the code to generate the final sample. Here is the file. Let me copy and run this one. As the clicks file is used, it will take some time, a minute or so, and produce the final file. So let me go through the program here. So I have clicks and buys is reading from the CSV file and created a data frame. I'm creating two temporary tables, clicks and buys. So I'm joining these two tables and aggregating it and getting the final output of total clicks, total time spent and a buy indicator. Finally, I'm writing this file into my CentOS directory. with the name of click data. I'm selecting only 150K data for my prediction sample. So once the file will be generated, I'm expecting a directory called click data. The file will be dumped in this directory. The clicks is still ready. Now it has been written, and as you can see, the click data started writing into the file. Let me move the file. So the final file has 150K. Let me move this file to the central, the C directory, where NIME will be reading and taking the input. So here is the file. Let me copy the file here. Let me go to the NIME environment to show the demo. NIMEs have the collection of organized nodes to predict a model. I have used two models, decision tree and logical regression model, to predict the purchase. The sequence of the workflows are starting with the CSV reader, where it is taking the file. I can run this to see the data. Here is the data. It has loaded 150K. Let me execute the whole process. I have used various nodes here. This one particular one, number to string, it is converting that Y variable to a string. Here I am removing a column session ID, which is not needed for the prediction. So my prediction variable would be total clicks and total time. I am partitioning the data. It's splitting into two sets, 80 by 20. 80 is the training set and 20 is the test set. I have the logistic regression and the decision tree here. Both the learner is taking the target column is by here. And then I have the predictor. And finally, a scorer is included here to score. The first column of the scorer is buy and the second column is the prediction buy in both of these models. Finally, I have included a ROC curve with the class column buy and positive class value as 1. As I already executed, I can see the result. Here at the ROC curve, it has given a value of 0.6195 and it has two important metrics: accuracy statistics and confusion metrics. It has given 93% score. The other scorer also given similar score, 90, around 90. So both model, the score is around same and has a good ROC value, indicates that the model is good and can be implemented. So as a lesson learned and pros and cons, I see NIMES offers various nice features and user-friendly open source. It's great for data pre-processing, analyze and visualization. It is great machine learning tool and easy to configure and run the model. However, NIME is not meant to replace as a reporting tool, but it would be nice to have monitoring and reporting capabilities. Also, NIME doesn't provide the integration with Jupyter notebooks. I also learned that the dataset I choose here has two variables to be taken, but if this clickstream data complexity to be increased, then we need to add more variables to it, and there is a scope to enhance the model on top of the current scope of the application. That's all from me today, and thank you all.